Okay, good morning. Sorry, we'll start again. So we're going to be talking about building business critical applications on AKS. We've got to thank our sponsors again. What a wonderful bunch they are. All of them, and yet there's more. So a quick introduction. My name's David, good-looking one on the right. Less good-looking one on the left is Dan, our CTO. So if you've got any difficult and unpleasant questions, please reserve them for Dan. So we wanted to talk very quickly about the last couple of years where we've all experienced dramatic change, and the theme of this really is the unexpected does happen. So a rank outsider at Wimbledon did remarkably well, but then went on to win the US Open, starting off as a 330-odd seed to go on and win. Remarkable. But for us, we've all had unexpected change in our lives. It's affected our business, it's affected our family relationships, and so forth. But what we do know about unexpected change is there's going to be more of it. The unstable environment means we're going to expect more flooding. That will create business disruption. So business agility during a period of unexpected change is really important. How can businesses do that? Well, often they'll go and get something off the shelf, a nice SaaS solution that nearly fits everything they want, and then they'll layer on top of it all the useful things to make it work as they want to work. But over time, their SaaS solution can become an impediment to progress because the vendors aren't interested in their specific business. So what's the alternative to that? Well, again, looking back on last year, there were two notable releases of some impressive platforms. You'll remember that the furloughing scheme was announced, up and running, fully working, along with the business continuity loan system within a week. Incredibly fast. How did they do that? Well, .gov is famous for using architectural patterns, imposing governance and data classification from the get-go, making the launch of new pattern-based sites really easy. By contrast, the NHS didn't with their track and trace app, and guess what? Far less successful, protracted, and so forth. But because we're living in times of change, the customer attitude is such that people expect great speed. So if I've got a problem, it doesn't matter, I can get somebody to build me a bespoke Power App, that will fix it quickly. I want it now. I can get Power BI, they can give me real-time reporting very quickly. It's all about speed because the cloud brings all of these good things. But here's the question. Better than a SaaS solution that doesn't fit, is it worth me taking the risk of building something cloud native from the get-go? And how do I know what to build? Dan.
Thank you. Morning. So I'm going to show you a video of a case study with our client Explore Learning. The interesting thing with Explore is, well, the lockdown here in March 2019, it feels like years ago and only weeks ago at the same time. And we got the phone call we were sort of expecting. They've got 143 centres across the country, 4,000 staff and 35,000 members. How do they keep running their business when all of their centres close down? Let's find out. So, Explore have done pretty well going down the bespoke route. Right. Oh, had skip. Right. So, it looks quite cheerful. You've got Bill there explaining the benefits of going down the self-build route. But it wasn't quite that simple, right? It was complicated. So the scaling requirements of Explore were massive. Like children, when they went into centres, would finish school at 3 o'clock and use the software, and then sessions ended around 8:30 p.m. So with the software we built, had to basically go along with the exact same sort of time frame. So we had to scale from nothing at any time before 3 o'clock up to going at 2,000 miles an hour, basically, to handle all the thousands of sessions. So we've got something like 1 million questions being answered a week by Explore kids, basically using their sessions. And we built that, as you'll see here, with the tutor actually on screen. We didn't build this with some sort of Teams or Zoom add-in or anything like that with screen sharing. We actually built native video conferencing directly into the browser so that tutors could tutor like up to 5 kids at the same time. And the tutors got the exact understanding of where that child is with their skills and their progressions on screen at hand, so they can provide the best experience. And that was all done with Azure Kubernetes Service, AKS. And that was definitely a voyage, if you want to excuse a terrible pun, but it was worth taking nonetheless. It was complicated, it took us quite a long time, but the benefits were there. So, why use AKS when you could just use something like App Service? I don't know whether anyone knows what App Service is, if they've used it in the past. So for me, App Service a couple of years ago was basically my bridge to the cloud. I would take a web app that I'd worked on, IIS or a VM, use App Service, brilliant, okay, it works in the cloud. But this basically would have not been suitable for App Service, because what we built here wasn't just a simple web application. It's a complex logic engine that's basically tailoring the answers and questions that are presented to children based on their progression path. It was developed in conjunction with Explore's data scientists. It's basically doing millions of calculations all the time. And so it's a complex combination of lots of different microservices and APIs. App Service wouldn't have cut it, basically. So we used AKS instead. Just to give you an example of the scaling I was talking about earlier, this is a single day. That's 2 o'clock, 3 o'clock, 7 p.m., 8 p.m. Interesting thing with this is that we are actually trying to get as much bang for our buck as possible in terms of the environment. So traditionally, what you would do, well, pre-cloud traditionally, what you'd do is you'd buy the most expensive server you could afford that would basically, hopefully, get as near as, or handle this sort of level as possible. It would cost you a massive amount of money. What you do with App Service maybe is you'd scale, but you'd have quite a level of comfort to make sure that if it suddenly got much busier, you're not going to get loads of denied requests or whatever. What we're doing, because we're using AKS with Kubernetes, is we can auto scale extremely quickly. So actually what we want to do is get utilization as much as we can brave it and without sweating to 100%, because we know we can scale up extremely quickly. So basically, rather than having it over-provisioned, we have it provisioned as close to over. Anything that's over is a waste of money, basically. So you just try and keep a tiny bit over, and then you just scale as quickly as possible. So that was a slightly different technique to what I think most people would be used to with cloud computing. The architecture, I don't expect anyone to be able to even read this from here. But what I'm trying to get at is, this is what we built. Everything else is just Azure PaaS services. And that is a consideration, which I'll speak about in a second. So what we could have done is, so we were using like SignalR and Redis, but we could have, in fact, we did self-host some of that stuff inside our own Kubernetes cluster. And then we took the decision, actually, we don't want to do that. We want to have that external and use just the Azure PaaS stuff, so we can concentrate on what our own code is doing, our core focus, basically. So there were quite a few learnings and considerations that we took that, you've got all the theory around Kubernetes and so on. We went through a year of actually running it, scaling it up every day and so on, and getting auto-scaling working and all that sort of stuff to learn actually in practice what works for us. And I guess other stuff that you wouldn't know about unless you started down the path of using AKS and Kubernetes were things like the readiness and health checks. So I guess auto-scaling is great, and then when you scale down, what you don't want to do is scale down so with people still using the nodes or VMs that have just been removed from the pool, basically, because otherwise those people had basically been abandoned. So there's lots of that which we just had to get to grips with. I've got loads of notes and resources on how to, if anyone's like technical and wants to know more about how to do this, come and speak to me at the stand. It's just over there. There's also notes in the slide. Microsoft just released a massive Kubernetes bundle on how to actually get to grips with this. And there's also like the reference architecture that you can download. It's complex and it's really well detailed, but David, probably you can explain how you can probably get started slightly quicker.
Thank you, Dan. So with all of that in mind, and the complexity around Kubernetes, and going back to our original discussion about the need for change and being able to respond quickly, and the benefits that we saw with the .gov site of the pattern-based architecture approach, what we've got is a solution, as you can see, that allows you to rapidly build your own cloud-native applications, have them in Kubernetes, architected with all the entities, roles, data classification types, get all of that architecturally right in about a day or so, and then you can launch and run your release of software, and all of the code will be populated into GitHub repositories, user stories into Jira, and your Kubernetes will be set up in your environment, your AD will be working, and so forth. So effectively, it's an out-of-the-box catapult, hence the name of the product is Catapult, to launch you with an architectural best practice pattern of business application in the cloud from the get-go. So if you wish, this was part of our thinking. I'll show it to you in just a moment. The idea being, instead of these protracted discovery periods where you do all the user gathering and so forth, this is a great quote. Put an application in front of your stakeholders. They can see what it does, and they can see where the gaps are and what they want. And we give you that starting point to go and see your clients with a solution, 80% there, all the background architectural difficult stuff done, and then you layer on top the value add that the client needs to make it really fit their requirements. So this is what the system looks like. We're running very quickly out of time. This is what the system looks like. It allows you to build entities and so forth. If I can, I'm just going to switch screens and show you the interface. So this is me now in Think Catapult. I choose one of the clients that I've got, go into one of their specific solutions, and here I can see all that I've built. But I can go in and have a look at my domains. I can build out my entities, see the relationships between them all, my policies, what kind of data restrictions I've got and so forth. So all of this is built by my team very, very quickly, and then I can go in and carry out a run, and it will go through and launch my software, accomplishing all of these elements, so that I will have my source software ready to go. Now if I just go back into my dashboard, I should be able to show you So this is an example of the output. But you put your own CSS in, your own logos, and so on and so forth. But this is the starting point you'll get with all of the entities appearing and surfacing as you designed it in the tool. So if you'd like to know more, we're just over at stand 14, just behind you. If you want to talk architectural patterns, we're the exciting bunch. If you want to talk Kubernetes, Dan's your man, and Matt has significant expertise as well. So do come along and have a chat, and then you can get a cricket ball as well for your pains. Thanks very much for your time.